Thus far in Chapter 9, we've taken the time to look at adding and subtracting, multiplying polynomials, looking at some different patterns that occur when multiplying polynomials. And finally, today we're going to use these skills or these properties to solve polynomial equations now. Okay, so before we were just simplifying expressions, right? I would say, hey, multiply out, and that was it. Today we're actually going to solve polynomial equations. All right, and so that's the goal. By the end of the lesson is that you're able to solve polynomial equations that are already in factored form. So there is one critical property that we do have to talk about before we just start solving these equations, and that is the zero product property. This is a huge property. You're going to see this over and over again, not only this year, but also next year in Geo and even on into Algebra 2 as we're solving various equations. It says let A and B be real numbers. It says if AB equals 0, in other words, if the product is equal to 0, then what that means is that A or B have to equal 0. All right, in plain English, oh, sorry about that. Let's see if I can... All right. In plain English, here's what it says. If you have two or more numbers that multiply together to get 0, then one of them is 0. Because again, hopefully at this point, at this stage of the game, you should all know that the only way to multiply two things or more to get 0 is if one of them is 0, right? So again, zero product property is huge. You have to know it. Okay. So one thing to note here, the solutions that we're going to be talking about, the other thing I could say find the solutions of the equations below, or I could also say find the roots or the zeros. So the roots and zeros are just fancy terms for solutions. Okay, so don't let that throw you off. Don't let that confuse you. Just some math terminology. So what we're going to do is we're going to go through and we are going to solve numerous examples here. Okay, so the first we have a set of 3 here first. Okay, and so again, if this term multiplied by that term equals 0, then what does that mean? That means one of two things. Either the x minus 3 has to be 0, or the x plus 2 is 0. Okay? No way around it. One of those two things have to be true. And now what you do is you solve these equations separately. So I look over here, I add my 3 to both sides, and so what that tells me is that x is equal to 3, or when I subtract 2 from both sides, x is equal to negative 2. That is the solution to this equation. Okay? Well, how do I know? We'll plug 3 back in for x. 3 minus 0 is 0. It doesn't even matter what this term is now. It would be 5, but 0 times 5 is 0. Plug your negative 2 back in. Negative 2 minus 3 is negative 5. Negative 2 plus 2 is 0. Negative 5 times 0 makes 0. Again, that's the beautiful thing about algebra and solving these equations is you can always go back, plug in your solutions, and make sure they work. Okay? Second guy here again, before we would multiply this out. We don't want to do that. We want to solve. So I have two things multiplied together to get 0. So what does that mean? That means that either 2x minus 4 is 0 or the x plus 1 is 0. Okay? Well, if the 2x minus 4 is 0, well, that means that I add 4 to both sides. I get 2x equals 4. Divide by 2. And so I end up with x equals 2. Or the second part of this is subtract 1, x equals negative 1. Okay, so your solution would be x equals 2 or x equals negative 1. Again, plug them back in mentally, and you'll be able to identify whether or not you're doing them correctly. The third example, again, my encouragement to you, pause the video, try it on your own, see what happens. So we get 7 minus 2 equals 0, or 3x minus 5 equals 0. And I go through and I solve these two independently. Add your 2 to both sides, so you get 7x equals 2. Divide both sides by the 7, so that cancels. And you're left with x equals 2 over 7. And over here, when I solve this equation, add 5, I get 3x equals 5. Divide by 3. So x equals 5/3. Your solution? Very simple. X equals 2/7. or x equals 5/3. I know it's not a pretty solution, but nobody ever said that your solutions always have to be nice whole numbers or integers for that matter. Okay, it's very simply whatever your algebra tells you it is. Okay, so again, you can plug those back in and make sure they work, but they do. Okay. All right, so now suppose the equations aren't already factored for us. We got a little bit of work to do. Okay, so what I'm going to constantly say is I'm going to say you have to look for the GCF. The GCF, greatest common factor. Okay, factor out the greatest common factor first, and then try to factor everything else. Okay, so the first couple examples we're going to look at here now are very simply just factoring out the greatest common factor. Okay, that's it. We're not going to mess with anything else. We're not going to try to solve anything yet. We're going to get there. All we're trying to do is factor out the greatest common factor. So I look at this first example, part A. I look at the first term, I look at the second term, and I ask myself, what can I divide or what can I take out of both terms? Okay, well, I know at the very least I can take out a 2 because 12 and 42 are both even. Okay, I can go one step further and say, oh, I can take out a, I know I can take out a 6. Okay, because 6 goes into 12 twice, 6 goes into 42 7 times. Okay, can I take out a 12? I do a little bit of thinking and I realize, well, 12 doesn't divide evenly into 42, so I can't. And so long story short, the greatest common factor of these two terms is 6. So then when I pull the 6 out in front, I pull it out in front, and so when I divide 12x by 6, I have 2x left, and when I divide 42y by 6, I have 7y's left, and that would be my factored form here of that original expression. Okay, that's just factoring out the greatest common factor. Okay, again, I look at the second example. Factor out the greatest common factor. I look at the whole numbers out in front, or the coefficients, I should say. I look at 6 and 36. It doesn't take a rocket scientist to figure out pretty quickly that 6 goes into 6 once and 6 goes into 36 6 times, so 6 is the term I'm going to factor out. Now I look at my variables. I see x to the fourth, I see x to the third. Okay, you can always, if your variables are the same, then you can factor out a variable. Namely, in this example, I can factor out x to the third out of both. Okay, so when I divide 6x to the fourth by 6x to the third, which I'm factoring out, okay, remember when you're dividing, we could do it off to the side here. Really what we're doing in our heads is we're doing this. Our original term divided by our greatest common factor, those cancel just to leave me with 1. And remember, when you divide two terms that have the same base but different exponents, you subtract your exponents. 4 minus 3 is just 1. Okay, so I just have x plus 6 goes into 36 6 times, x to the third and x to the third will cancel each other out. So my final answer would be 6x to the third parentheses x plus 6. Okay, this idea of factoring out the greatest common factor is going to take probably a little bit of time for you to really get a gauge on, okay, and really to feel comfortable with. So no worries if you're feeling a little bit overwhelmed right now. Okay, so again, I look at the terms and I say, okay, immediately I see, and again, this is just my experience. I've done this for a while, so I understand now how to identify the greatest common factor pretty quickly. I know for sure I can factor a 5 out of both terms, and then I have x squared and x, so I know I can just take an x out. Okay, and so what I ask myself now, 25 divided by 5 is 5, x squared divided by x is just x, minus 5 goes into 35 7 times, x goes into x once, so nothing's left there, and so all I have now is 5x parentheses 5x minus 7. Nice thing is you can always check this, mentally distribute. Okay, 5x and here's what I'm thinking when I double check, 5x times 5x, 25x, 5x times negative 7, negative 35x. Okay, I'm good. Check. It worked. Okay, I'll do a couple more here, and then we'll get to some solving. We'll do part D, and then I'll call it a day here as far as I'm concerned. But you guys should probably work through the last two there on your own. So again, this just comes with experience, but I think of the biggest number that divides evenly into 12 and 16, and hopefully you recognize fairly quickly that that number is 4. And then I look at my variables. Okay, there's an m to the second in my first term. There's no m in my second term. So as far as my m's are concerned, I can't do anything. I can't factor anything out. Then I look at my k's. I have 1k here. I have 1k there. Okay, that means I can pull 1k out of both. Okay, and then finally, I look at my p's. I have 3 p's here. I have 2 p's there. So that tells me I can take 2 p's out of both terms. And so now what I'm left with is this. 12 divided by 4 is 3. We already said we're not doing anything with our m, so our m squared's got to stay. The k is already factored out, so that's gone. I factored out a p squared, so if I factor out a p squared from p cubed, the only thing I'm left with is p, plus 16 divided by 4 is 4, k divided by k is 1, p squared divided by p squared is 1, and so my second term just stays as a 4, and so there's where we're at. Again, you can multiply through and make sure you did it correctly. That's the beautiful thing about algebra is more times than not, you can check your answer. All right, so my encouragement, try the next 2 on your own. We'll go over those in class tomorrow just to make sure that you're all ready to go with factoring out the greatest common factor. All right, and so now this one is going to kind of extend both of the ideas we just talked about. So I have 14y squared plus 21y equals 0. What we're going to do is we're going to factor first and then solve, because it's really hard to understand what I can plug in for y right now in order to get 0. Okay, and we got to make sure we find all zeros. If the degree of the polynomial is 2, that means we have 2 solutions. Okay, remember what degree means? It means the biggest exponent. So 2 is my biggest exponent. So I have 2 solutions here. So I think about what can I factor out of both terms? Well, I know I can factor out a 7, and I see I can factor out a y. 14y squared divided by 7y is just 7y. 21y divided by 7y is just a positive 3 equals 0. And now we're back to the zero product property. This term times this term equals 0. So what does that mean? That means either the 7y is 0 or the 7y plus 3 has to be 0. Divide by 7 here. So y is either 0 or, when I solve this side, I get 7y equals negative 3. Divide by 7 on both sides. Y is negative 3 over 7 would be my second solution here. Okay? Again, factor out the greatest common factor and then use your zero product property. All right, the second example, it's going to be a common theme again and as we get rolling here, but you got to pull everything to one side first. Okay, so in other words, I got to get all my terms to one side. Doesn't matter which way you do it here. I'm just going to go ahead and subtract 3c from both sides. So those cancel, and so what I'm left with is 6c squared minus 3c equals 0. Now I'm going to factor out the greatest common factor. So I factor out the 3c from both terms. Remember, I can factor out a 3 from 6 and 3. I can factor out a c from c squared and c. So when I do the division, 6 over 3 is 2. C squared over c is just c. And then I have minus 3c over 3c is just 1 equals 0. And again, if I have 3c and 2c minus 1 multiplying to get 0, that means either 3c is 0 or the 2c minus 1 is 0. And now I solve these independently. So c is equal to 0, or when I solve this guy, I get 2c equals 1. So that tells me that c equals 1/2. Okay, so c is either 0 or it's 1/2 in order to be a solution to the original equation. All right, so again, the last 2 examples are no different. Factor out your greatest common factor and then use the zero product property again. We will discuss both of those examples when you get to class tomorrow, so make sure that you guys take the time to work through them. It's a good gauge for you to see where you're at, see if you understand what we've discussed in this video, and we'll go from there.